This is 9.3. We're talking about probability again. And the big thing that we're going to talk about is odds in favor. How to find the odds in favor of something. And how to find the odds against something. Okay, first of all, you see these formulas with all the P and the A and the whatnot. Okay, your homework might use the phrase wanted or favorable outcomes for the P of A. So regular P of A means the wanted outcomes or the favorable. The piece of the formula that does not have this wanted is the unwanted or the unfavorable. So that capital P of A, that means what we're looking for, what we're hoping for, and then the unwanted is what we don't hope for. Okay, so let's see here. It says 2 dice are rolled. Find the odds in favor of rolling a sum equaling 5. So I gave you a little chart over here. Your homework will do it also. Sum means you add them up. You add the sides of the dice to equal a 5. And this chart says that if you add up the sides of the dice and they equal 1, that only happens 0 times. Or it happens once that you can add up the sides of the dice and get a 2. It happens 6 times that you can add up the side of a dice and get a 7. Okay, so when I say roll a dice, I mean, let's say you have 3 and a 1 that pop up on your dice that are face up. You would add those to get 4. So whatever face is facing up, that's what you add with the other sucker to get the sum. Okay, so it says we need to figure out the total amount of times this happens. So we're going to add up all this numbers under the word count or the word frequency. Okay, so we're going to add up all those numbers, and you should get 36. So that means there's 36 total times this happens. These are all the possibilities. There's 36 possibilities, and adding up their faces could equal a 1, 2, 3, 4, and the frequency is how many times it happens. Okay, so to equal a 5, we want the odds in favor. So odds in favor looks like the wanted over the unwanted. Okay, so let's look for the equaling of 5. Equaling of 5 is right here under sum of 5, and it happens 4 times. So it says find the odds in favor of rolling a sum equaling a 5. That's the wanted piece. So across from the 5, I see a 4. That's what goes on the top of the fraction. Unwanted is how many there are that do not include this 4. So what we're going to take is we're going to do the total 36, and we're going to subtract off that 4 we just found. So equaling a 5, when I toss 2 dice, will happen 4 times, and it will not happen whatever 36 minus 4 times is. So this will be 4 over 32, and then go ahead and reduce, and it makes 1 over 8. And you can either type 1 divided by 8, or you can type 1 semicolon 8. Okay, let's look at part B. Part B says rolling a sum greater than 4. So what numbers are greater than 4? 5, 6, 7, 8, 9, 10. Yeah, you get that. Okay, and we're looking for a sum that's greater than 4. So what sums are greater than 4? 5, 6, 7, all the way up to 12. If it would have said greater than or equal to 4, then I would have go ahead and included this 4 in my circle. Okay, so we still want the odds in favor. Odds in favor are what we want over what we don't want. So let's see what we want and we don't want, the unwanted. So let's see here. To figure out what we want, we already found the sum greater than 4. It's all these numbers in here. But now we need to add up all their frequencies, and that will be the wanted. So we're going to take all these numbers now on the right and add them up. So the wanted is 4, 5, 6. Let's see, 4, 5, 6, 5, 4, 3, 2, 1. Okay. So these numbers come from adding up the sides of your dice and getting something bigger than 4, like 5 through 12. Okay? Now what's the unwanted? Well, if these were the unwanteds, if these were what we were looking for, the unwanteds are up above, this 0, 1, 2, 3. And you might do this differently. You might use subtraction, but we should get the same answer. Let's see what we get. Hmm, 11, 15, 20, 24, 27, 29, 30. Okay, so on top, I get 30. On bottom, I get 6. And then we're going to reduce this. But when we reduce it, let's leave the 1 in the fraction. So if I divide this by 6, we get 5 over 1. Or that's the same thing as 5 semicolon 1. Yay! Okay, let's look at this less than or equal to 7. Okay, so let's do part C, less than or equal to 7. We're still doing the odds in favor, so we still do the wanted over the unwanted. Okay, let's find the portion that has sums less than or equal to 7. So here's my sums column on the left. 7 is right here. And this time, it's less than 7, so anything below it. Okay, and then the counts matching with that are 0, 1, 2, 3, 4, 5, 6. And then the counts that do not match with these are this down below, 5, 4, 3, 2, 1. And you might come up with the same numbers as me, but you use like subtraction. It's the same thing, as long as we get the same answer. Okay, so on the top we get 11, 15, 18, 20, 21. And on the bottom we get 15. Okay, and then if I reduce by 3, I think it makes 7 over 5. So it would be 7 semicolon 5. Yay! Okay, let's look at part D. Part D says something about an odd number. Okay, well, where are the sums that have an odd number? Here's a sum that's odd. Number 1. 3, 5, 7, 9, 11. Okay, and you're going to add up the counts that are associated. Okay, and we're still doing odds in favor. So we want the wanted over the unwanted. Okay, so the wanted are those counts that I circled from the odd numbers in the sum. Okay, the unwanted are the counts that I did not circle in purple that match up with your even sums. So 1, 3, 5, 5, 3, 1. Okay, and then let's add these up. 6, 12, 16, 18. And FYI, every time we come up with one of these fractions, the top and the bottom should add up to your total amount of counts. So see how I have 36 counts? In this fraction, 4 plus 32 is 36. In this fraction, 30 plus 6 is 36. In this fraction, 21 and 15 added up to 36. In this fraction, 18 over 18 added up to 36. So if at any point your two numbers on top of each other don't add up to that total, you probably did something wrong. Okay, and then let's see, if I reduce this 18, it just turns into 1 over 1 or 1 semicolon 1. You have a 1-to-1 chance. Okay. Enough of that. So far, all we've done is dealt with this odds in favor formula over and over and over. Odds against is pretty much the same, only it's flipped upside down. Alright, let's look at this next question. It says, if the probability of a child being a girl is 1/2, and a family plans to have 4 children, what are the odds against having all girls? Okay, so let's see. We're having 4 kids. Yep. And we want to know the odds against having all 4 kids be girls. So that's G, 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 G. That's 4 girls. Okay. Okay, so this 4 girls, that's the portion that's wanted. Okay? And that's only one possibility. There's only one time that you could have 4 children and they all be girls. It looks like G, 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 okay? But how many total possibilities are there? Because if we can figure out the total possible, then maybe we can do some subtraction or something. Well, let's see here. If I have 4 girls, if I'm giving birth to 4 children, 4 children, that means 4 boxes multiplied together. And how many different children could you have the first time one pops out? Well, I could have a girl or a boy. So that's 2 possible kids. Okay, what about the second time I have a child? How many different kinds of kids could I have? I could have a boy or a girl. That's another 2 possibilities. Okay, what about your third child? I could have a boy or girl. Your fourth child, I could have a boy or girl. So these 4 boxes are from 4 children. If your homework problem says 3 children, you draw 3 boxes. The 2 comes from the fact that there's only 2 genders that could pop out of you, female or male, when we're talking about math. Okay, now if the wanted is just 1 possible, the total possible is this 2 times 2 times 2 times 2. And that makes a total of 16. Okay, well, let's think about the unwanted. So this means there are 16 possible combinations of your children. You could have boy, 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 girl. You could have boy, girl, boy, girl. You could have boy. And if I kept listing all those options, all those possibilities, there would be 16. Okay, so if there's one option of what we wanted for girls, how many possibilities are there of what we don't want? Well, if there's 16 possible combinations that our children could pop out as, that's 16 total possibilities. And then if there's only one possibility that we want, we subtract 1, and that gives us 15 for the unwanted possibilities. So we only want 4 children if they're all girls. If they have a boy mixed in, we don't want them, and there's 15 of those. Okay, now let's look at the formula for odds against. Odds against formula is bass-backwards. It's the unwanted on top of the wanted. So this time there are 15 possible combinations of children that I don't want because they involve a boy. Whereas there's just one possible combination of 4 children that I do want because they'd all be girls. Okay, so the question is, what are the odds against having girls? 15 to 1. That means out of 16 possibilities, you have 1 chance of having all 4 girls in a row. Okay, let's keep looking underneath. It says find the odds against. That's the same formula we just used. Unwanted over the wanted. Okay, and it's or never mind. Okay, and it says find the odds against a randomly chosen, and whatever comes after this is the quote wanted portion. Okay, so it says find the odds against a randomly chosen household having a cat. That's the wanted portion. It's the having a cat. Basically, it's whatever the words they tell you in the problem. So the wanted is having a cat. Okay, and it says if the probability of the event of a randomly chosen household cat is 0.23. So the wanted probability is 0.23. And this is kind of weird because we're using a decimal, but that's okay. So let's put this 0.23 on the bottom. Okay, well, let's think about this. What's the biggest probability you can have? Well, as a percentage, it's 100%. As a number with a decimal, it's the number 1. So, the largest probability we could have is a 1. Well, I know having a cat is 0.23. Well, the unwanted is going to be not having a cat. Well, not having a cat is just like subtraction. We're going to take, kind of like this 16 minus 1, only we're going to say something minus 0.23. And since the biggest probability we could ever have is 1, we're going to say 1 minus 0.23. Because this means if you got a 0.23 chance of having a cat, and whatever this is of not having a cat. And this would be 0.67. Okay, so we throw those on top of each other into this formula. And then this is kind of weird. If you try and put this in your calculator, it goes berserk. It won't do it. So we're going to do something kind of awkward. You remember earlier how when we had that fraction, we divided by 4 or we divided by 6 to get smaller? Well, instead of dividing, we're actually going to multiply something. We're going to multiply by 100 here. And what that'll do is it'll get rid of these decimals. So let's say 0.67 times 100. And it got rid of my decimals. It gave me a 67. And then 0.23 times 100 is 23. If I would have had a fraction with bigger decimals, then I would multiply by not 100 anymore, because here I multiplied 100 to get rid of the 100th spot. Here I would multiply by tens, hundred, thousands. So if you got a decimal that was ridiculous, multiply by something bigger. So if you have 3 numbers in your decimal and that 4 ends in the thousands, you multiply by 1,000 to get rid of the decimal, and it just gives you the big old fat whole numbers left. Okay, so anyway, to get rid of those decimals, we multiply by 100, and then that cannot reduce. So that is the odds against, or how else do we write it? With a little semicolon. 67 semicolon 23. Woohoo! Let's go again. On the right, it says, from a set of 13 marbles. Okay, let's write this down. There's total 13 marbles. All right. 4 are blue. And 9 are green. We choose one at random, and then it says, what are the odds in favor? Okay, well, odds in favor formula are the wanted over the unwanted. Or the wanted over what we don't want. Okay, well, it says, what are the odds in favor of choosing a blue marble? Whatever comes after that phrase, choosing, or odds in favor of choosing, whatever comes after that is the wanted. So since it was talking about the blue marble, that's the wanted. Okay, so let's use our formula. How many blue marbles do we have? 4, okay? And then how many marbles are there that we don't want? Well, I could either say 13, because that's the total, minus the blue, 4, or we could just say 4 over 9. Yep. And if I write that with semicolon, it's 4 semicolon 9. Woohoo! Okay, part B. It says, what are the odds against? So let's pull up our odds against. It's not wanted or unwanted over what you want. Okay, and it says choosing a blue marble. So wanted is still the blue marble. Whatever comes after the phrase, odds for, against, whatever, choosing, whatever comes after that word choosing is what is wanted. So the wanted is the blue, and that's 4. Not wanting, again, you could either do 13 minus 4 or 9. Either way, it's 9 to 4. All right, let's go again. The next sucker says, suppose the odds against, odds against, let's come up with that formula. The odds against formula is unwanted over wanted. Okay. Okay. It says, suppose the odds against winning the lottery are 44 to 1, or 44 million, whatever this says, to 1. Okay, so they've given us these kinds of numbers different ways. We just did an example where they just gave us how many marbles we had, how many objects we had. We did another example with the cat where they gave us the probability as a decimal. Here, they're giving us the odds in favor as a fraction. This 44, blah, 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 that's the number that goes on top. The number 1 is the number goes on bottom. Okay, so let's figure out how many total people are there. Well, let's remember how to get the total from a fraction like this. Remember earlier when I said this fraction was supposed to add up to 36 because that's what the total was? 4 plus 32 is 36. 30 plus 6 is 36. This 15 plus 1 is the total 16. Yeah. This 4 plus 9 is the total of a 13. Yeah, you get the point. Okay. So, to figure out the total, we're just going to add this 44 number and that number 1. And it makes 44, that number, with a 1 on the end. Okay, now let's figure out what the question was asking for. It says, what is the probability of the event of winning the lottery against these odds? Okay, well, what's the probability? The probability is equal to the part over the whole, or the wanted over the total. So let's see here. How many people do you want to win the lottery? 1. You want to win the lottery. So that's 1 over. How many total people played the lottery? Well, this says 44 million and 1. So the question is, what is the probability of winning the lottery given these odds? 1 and 44 million and 1. What? Okay, let's look at this expected value and fair game. Expected value just means how much money you expect to be there total. Okay, fair game means when the price you pay to get into the game is equal to the price you make off the game. Okay, so let's look at this little formula right here. It says capital E, that's the expected value. Okay, and expected value is money, honey. So our answers are going to be money. And the lowercase p are the probabilities, as in, you know, fractions. Lowercase a are what the items are worth, as in the money. And yeah, let's go. It looks like this formula multiplies things with the little dot, and then there's a plus sign. Then multiply with a little dot and a plus sign. Multiply with a little dot. Okay, let's see. It says, suppose 2 quarters, 10 dimes, 7 nickels, and 5 pennies are in a box. 1 coin is collected at random. What is the expected value of the money drawn from the box? Okay, so first, we're going to say capital E equals little a. Little a is how much the items are worth. So how much is a quarter worth? A quarter is worth 25 cents. Okay, so I'm going to write down 25. Then I'm going to multiply it, or I think I'm just going to use parentheses to make it pretty. That means multiply it. By the lowercase p are the probabilities. Okay, so let's find the probability of getting a quarter. Well, I know there's 2 quarters. What I don't know is the total. let's figure out how many total coins we got here. We got 2 plus 10, 12, plus 7, 19, plus 5, 24. Okay, so the 25 comes from 25 cents. That's money. That's how much the quarter is worth. The fraction is the probability, as in there's 2 quarters out of 24 total. Okay, then the formula says plus sign. 10 dimes. How much are dimes worth? They're worth 10 cents each, and we're not using a decimal here. It's okay, don't panic. Okay, what's the probability of these dimes? Well, it's the part over the whole, or the part over the total. There's 10 dimes, and there's 24 total coins. Plus, let's keep going. How much is a nickel worth? A nickel is worth 5 pennies, so 5 cents. And then what's the probability of this nickel? Well, there's 7 out of 24, because there's 7 nickels and 24 total. Plus, lastly, there's pennies. How much is a penny worth? 1 cent. Okay, what's the probability of this penny? Part over the whole, so 5 over 24. Okay, now we're going to multiply these, and I'm just going to go slow. I'm going to say 2 divided by 24, like I did the fraction first. Let me show you that again. 2 divided by 24, and then times 25. If you have an awesome calculator, you can put this all in straight up all at once. I'm a little slow though. Okay, so anyway, from here we get 2.083. Okay, let's do the next one. Fraction first. 10 divided by 24 times the number on the outside. And we get plus sign 4.166. Let's write down 3 decimals. Plus sign. Fraction first. 7 divided by 24 times the number outside. 1.458. Plus lastly, 5 divided by 24 times the one outside makes 0.208. Okay. All right, now let's add up all these decimals. And I got 7.915. Let me write that down over here. 7.915. And this is supposed to be money, honey. So how do we round money? We round money with 2 spots. So this should be $7.91. Woo! So that's not how much all that money is worth. It's how much money you could make considering the probability of pulling each one of those coins. Okay, let's look at this next one. It says in the odds, if the odds in favor of Fast Leg winning a horse race are 5 to 4. Okay, well first let's decode this. Odds in favor. The formula for odds in favor is wanted over unwanted. Okay, whatever comes after, well actually I think they give us 5 to 4. That's kind of like when they gave us the lottery of 44 million to 1. We just put those numbers straight up in the fraction. Same thing here. This 5 to 4, we're just putting it straight up in the fraction. Okay, so we need to figure out what this wanted is, whether it's winning or losing. So after the phrase odds in favor, it should say either something. It should say something. Oh, winning a horse race. So the odds in favor, that means 5. There's 5 chances you could win and 4 chances that you could lose. Okay. How many total possibilities is that? Remember, to find the total possibilities of outcomes, you add the numbers on top of each other in your fraction. And that should always come up to your total number of outcomes or possibilities. Well, if we add ours, we get 9. Okay, let's read the rest of the question. It says, and the first prize is $18,000. What is the expected value of Fast Legs winnings? Okay, well, first we have lowercase a, which is how much the item is worth. So how much is it worth to win? Well, it's $18,000. Okay, then we're going to multiply it by the probability that you would win. So, what's the probability that we will win? It's the part over the total. The total is 9. That's the number we just found. The probability of winning, where's our winning number? 5. Okay, so now we're going to put this in our calculator, and this should give us the capital E. So first we do the fraction first, unless you have a fancy calculator, and then we multiply by 18,000. And we should get 9,999.99. Yeah, okay. And it'll probably say something about round to the round like money. Well, if we round like money, honey, that means I look at the third spot, and that 9 is 5 or more, so we up the score, 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 and it knocks all these 9s up to zeros, and it finishes at 10,000. And that's money. So, if the odds in favor of winning a horse race, specifically Fast Leg winning, are 5 to 4, and the prize money is $18,000, you could walk home with $10,000. You don't get all that money. Okay, let's look at this next sucker. It says, suppose it costs $22 to roll a pair of dice. That's the cost to get in, or the cost to play. This is the first time we've talked about the cost to play. Okay, it says you get paid 3 times the sum of the numbers that appear on the dice. Is this a fair game? Well, a fair game means the money that you could take home is the same as the money you put in. So, if I'm putting in $20 to play the game, it'll be a fair game if I can make $20 profit. That way I didn't lose anything. Okay, so the way we're going to do this sucker is we're going to say, kind of like this expected value formula, just with an extra multiplier. And that extra multiplier is this 3 times the sum of blah, blah, blah. Okay, so our formula that we're going to use is we're going to say the sum times the probability times $3, and then we're going to add that repeated over and over and over again. Okay, so we have to do this for all of these numbers. So if I roll an addition or a sum of a 1, let's figure out what the probability is. This takes us back to the very beginning. To find the probability, we did this somewhere. Well, my bad. Okay, maybe we didn't. But probability is the part over the whole. Yay. Okay, so this means the count over the total count. So for us, for the sum of 1, it had a count of 0, meaning it happened 0 times. But what's the total amount of counts? Well, let's add them up right here. I think it's 36. Yep, 36. Okay, then we're going to multiply it by $3. And then we're going to keep going. We're going to add the next sucker. 2 times his probability, which is the count. 1 over always 36 times $3. Then we're going to keep adding 3 times the probability, which is the count. 2 over 36 times $3. Okay, and we're going to keep doing this. Let me just go slow and maybe find some of these decimals real quick. First do the fraction, 0 divided by 36. Unless you have a fancy calculator. Then times 1 times 3. Oh, and that gives me 0. Let me keep going. 1 divided by 36 times 2 times 3. This makes 0.166. Yeah. And then we're going to keep going. 2 divided by 36, unless you have a fancy fraction. Then times the 3 in the front and the 3 at the back. So we have plus 499. And then we're going to keep going. Okay, this is getting kind of crazy. Okay, so we've just done this one, this one, this one. Now we're going to say plus 4 times its probability, which is the count, 3 over the total, 36, times $3. Plus the next sucker, 5 times the probability, which is the count over the total, 4 over 36, times $3. Yeah, okay, so I think you get the point. And then you find all the decimals and you add it all up. Yeah. So then we have to add 6 times 5 over 36 times 3. Then 7 times the count, 6 over 36 times 3. Plus the next sucker, 8 times the probability, which is the count, 5 over 36 times 3. Anyway, you get the point. Okay, and let's say all this equals $23. It doesn't. I'm not actually going to do it. It's going to waste our time. But let's say we get $23. That means the cost to play is $22. Well, that is not equal to the expected value. So it's only a fair game if this cost to play, 22, is the same thing as all these decimals added together, giving you 23. Okay, so this is not fair because it's not that 22 I started out with. If it was that 22 I started out with, then I would say, yes, it's a fair game. Stop taking